let's take an in-depth look at 3D vectors and 3D coordinate systems. One thing you must always ensure is that you're using a right-handed coordinate system. All right, so what is a right-handed coordinate system? Well, it's represented by your right hand. So take your right hand, place it out. All right, your thumb represents the x-axis. Your first finger represents the y-axis. And then your middle finger points directly straight out, and that represents the z-axis. And now I can rotate this all the way around any direction I want, and this coordinate system that I'm using, that I get to create, is always right-handed. Okay? So let's move to the desktop view here. And I know you look a little goofy with your hand out like that as you're solving problems, but we need to make sure that it's a right-handed coordinate system. So if I draw this on paper, all right. So let's just label these axes here. I'm just going to say x, y, and z, and I just scribbled down this information quickly. Is this a right-handed coordinate system? All right, so let's get out our right hand here, and I'm going to point my thumb in the x direction and try to point my first finger in the y direction. And what I find out is the z direction should actually be pointed downwards instead of upwards. So this is not a right-handed coordinate system. All right, to make this a right-handed coordinate system, we need to make sure we're going to flip-flop the y and the x-axis. Okay, so now I can put my thumb in the x direction, my first finger in the y direction, and the z should be pointed up. All right, so that is a right-handed coordinate system. So make sure you're always using a right-handed coordinate system here. Okay. Now, another thing is direction cosines, right? A lot of people get confused by this, but it's no big deal, all right? So remember our situation in 2D where we have, if I could draw, where we have an x and a y axis here, right? And we have our vector f, right? And let's say this is theta, and this is, let's call this angle gamma, right? So the x component here is equal to the magnitude of f, right? I better put a hat on this, show it's a vector, f cosine theta. And if we have this angle gamma here, we know that y is equal to f cosine gamma, right? So if we have all the angles between the vector and the axis, we can break these down into their components. Now, everybody loses their minds when we move to 3D with this system. So let's do that quick. So let's make sure that it's a right-handed coordinate system, x, y, z. All right, and let's draw a vector. And this is vector A here. And we'll be given angles here. So we can call the angle between A and the x-axis, we'll call that alpha. The angle between A and the y-axis we'll call beta. And lastly, the angle between A and the z-axis here we'll call gamma. Okay. With that being said, we can break these down into their components, right? So AX, get a different color here. AX is equal to A, the magnitude of A, cosine of alpha. All right, likewise, AY is equal to the magnitude of A cosine beta, because that's the angle between A and the y-axis, and Z follows the same sort of notation, cosine of gamma. Now these cosine alpha, cosine beta, cosine gamma, those have a name. So those are called the direction cosines. So that is 3D vectors, 3D coordinate systems, and direction cosines.